for the Embedded Systems course. Our project is for the Smart Classroom project. Here is the demo. The Smart Classroom project works in two modes, either the exam mode or the normal mode. What is displayed right now is the normal mode, where we display on the LCD the seatings. Those map to the front seatings. The seatings are simulated using push buttons to detect if a student is present or not. So, if we simulate that a student has sat in here, we light up the front row and we light the according LED to the student, and we show accordingly how many free seats are available. Doing another seating, and that's the normal mode. For the exam mode, we can flip between them using the inner switch. Here, the instructor is required to enter the duration of the exam using the serial input. So we will just input 20 seconds, and the LCD will start counting down for the duration of the exam. Once it reaches the end of the exam, a buzzer will notify the students that the exam is over, and while in exam mode, all the lights are open. And that's pretty much it. I'm Abdullah Al-Adi, and we will take a brief look at the connections. So, we have our common VCC and our common ground connected to both nodes on the breadboard, where we connected the VCC here and the ground to the ground and the VCC of the Arduino. And for all the inputs, as well as the outputs, here are the LEDs, the outputs. They are pulled down and connected with a resistor to the ground to be pulled down. The same can be applied for the buttons, where we pulled them down using one resistor. And same concept applies for the buzzer and for the switch button, where we switch between the exam and the normal mode. That's it.
My name is Mohammed Ibrahim. I'm in team 25 in the CSAN 701 Embedded Systems course. I worked on the modeling of the prototype of the project and the soldering needed for the circuit. I worked with the connections of the LCD to the breadboard. The LCD comes without pins, so we needed to solder header pins to be able to connect it to the breadboard. We grouped the wires connecting the buttons, the LEDs, and the push buttons that we used to switch between the exam modes. Here we have a potentiometer too to control the contrast of the LCD. As Abdullah stated, we pull down all the buttons and the LEDs to the ground. We have a common ground here, and we have a common VCC that we connected to all the components that needs to be connected to it. We also tried to make a model that is as minimal as possible. That is why we grouped the jumpers and the wires, and we have only 6 seats here. Also, we glued the wires here so it can be take less or fewer size, and that's it. Thank you.
Hello, my name is Amr Qaid. I was responsible for mapping the pins and the setup function with the LCD configuration, and I will show you the code now. Okay, for mapping the pins, we map the LED pins of the back seats to A2, A3, and A4, and for the front seats to A5. And here we map the push buttons to those pins. Then we map the mode button, which is responsible for normal mode and exam mode, to A0, and the buzzer to A1. and here we set a boolean for the front seats lights and a string for displaying text on the LCD. Here we configure the LCD as shown in this in this link we provided in the report. Then we start in the setup function by initializing the LCD and configuring the LED pin to be an output pin and the push button shares to be an input pin and the mode to be an input and the buzzer to be an output. Then we set up the frequency to 9600 megahertz.
I'm Ahmed Shawi from Team 25 and I worked on the exam mode in this project, embedded project. Here's the code. So at the beginning I wrote a while loop that constantly reads from the serial input and reads the input character by character, and if it is a digit it concatenates it in a string. Then when the user presses enter, I convert that string into an integer and then make a counting loop on that integer until it is 0. I decrement it until it becomes 0. At each iteration I clear the LCD, then I reset the cursor to column 0 and row 0, then I print the current value, then I put a delay of 1 second and then I decrement the value. I do this until the value is equal to 0. When the value is equal to 0, I put a high bit on the buzzer, then I clear the string and put a delay of 1 second so that the buzzer would work for exactly 1 second. Then I turn off the buzzer. Another condition is if the mode is high, which means that if the user wanted to change the mode before the counter actually resets. In this case I say that the value is equal to -1 as to break the loop.
I'm Mohammed Abu Ghazala. I'll be talking about the implementation of the normal mode. I'll show you about the normal mode. First, I reset the buzzer. Then, if any of the seats is occupied, we signal that the front seat will always emit light. The 3 LEDs in the front seat will always be on if any of the seats are on. Here we signal that if the front seats is high, we LED pin 4, which is connected to the first 3 LED pins, will be high. In this for loop, we check that if the button is pressed, then we signal that a chair is occupied, and then we increment the occupied count, and then here we print the number of the occupied seats and the number of the empty seats. Here. The final for loop is responsible for showing a model of the 6 seats in the LCD. If a seat is occupied, we print X, else we print 0. Here, this if statement is responsible for dividing the first 3 seats to be in the first row and the second 3 seats to be in the second row. And here simply, if the chair is occupied, we print X, else we print 0. The final switch statement is responsible for modeling the LEDs for the second row. Here is responsible for LED 1 from the left, here the second LED, and here the third LED. And respectively, if the chair is occupied, here it will have a value of 1, signaling the LED to be on. Only 3 cases because we only model the individual LEDs for the second row.